Okay, so we'll just have a look at a dependent series of equations here, and I'll just go through and solve it, or sorry, I'll find where the solutions are, and then I'll show you how you can actually establish all the multiple solutions. So just really quick here, I'll create a fourth equation, which is 1 minus 3, so x minus x, we get y plus z equals 15. And then a fifth equation where I might go 2 minus 2 lots of 1. So we know that planes 1 and 3 meet. So I should establish that first. And now we're going to see where planes 1 and 2 meet. But if I go 2x minus 2x, I get 0. 4y minus 4y is 0. So we get 0 on that side and we get 0 on that side. So that's true. So what that means is planes 1 and 2 are the same. So we get this situation where we have a plane coming down and it is cutting through two other planes. So it looks a bit like that. And so our solutions lie along this line here. Now, obviously, these planes go forever, so there's an infinite number. But in most situations, what we're going to find is the solutions need to be integers, and they also need to be 0 or greater. So what we're going to do is actually get the equation of that line, which we have here as y plus z equals 15. And I'm just going to rearrange it to make it z equals 15 minus y. And now all we do is we just start substituting valid values of y into here and checking to see what we get. So I'm just going to create a little table over here with my values. And so if I try y equals 0 there, I know that 15 minus 0 is 15, so z will be 15. So I just need to check, does that give me a valid value for x? So I'm just going to shoot up to one of my other equations, maybe equation 3, where we have x plus y plus 2z equals 25. And so I know now that that would be 0 plus 30, so x plus 30. So x would have to be negative 5, which is actually no good to us. So we just have to try a few more. So I'm just going to move up to now, let's try y is 1 and see what happens. So z will be 14, and that am I writing over there? Z will be 14 because 15 minus 1. And now when I put that in here, x plus 1 plus 28 is 25. So x would have to be negative 4, which is no good. Now you can see it's going down by 1 each time. So what I'm going to do is stop wasting my time. I'm going to jump y right up to 5, which would make z then 10 because 15 minus 5. And now when I substitute this in here, I've got x plus 5 plus 20 equals 25, so x will be 0. So that's our first valid solution. And from that pattern, we now know that we can actually increase y and keep going up. So if y is 6, z will drop to 9. We can see the pattern in the table, x will come up to 1. And so we can start to predict what all the solutions will be. And we can also work out how far can we go. So if y keeps going up, at some point, so if we just dot, 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 like so, z will become 0. And that's going to happen when y gets to, 15, I guess. And at that point, we'll have x plus 15 plus 0 equals 25. X will be 10. So we have a series of solutions there that range from 0, 5, 10 all the way up to 10, 15, 0. And so you would just have to give a starting, maybe a stopping value, and then a few in between, like I've done there.